I open my eyes and see a vast universe, unimaginable expanses of space and time. Moreover, the totality must be incomprehensibly larger, perhaps infinitely larger. I have so many questions. As for answers, science, I know, has them. Theology, I've wondered. Where to begin? Begin with the beginning. Everything has a beginning. So the universe had a beginning. No, not necessarily. Some scientists claim that the universe did not have a beginning. And some theologians contend that the universe did not need a beginning. What? No beginning of the universe? How'd that be possible? Science and theology can each challenge this common belief. Did the universe have a beginning? I'm Robert Lawrence Kuhn, and Closer to Truth is my journey to find out. Traditionally, in both science and theology, the cosmos was from everlasting, without beginning, until the mid-20th century when Big Bang cosmology was accepted. Beginnings bring meaning, and I start with the science. When we want to understand something, anything, we ask, where did it come from? How did it start? But some say the universe is different. Because the universe is not something, it's the whole thing. That's why, first, we ask whether the universe had a beginning. I begin with a cosmologist who focuses on the early universe, the Associate Scientific Director of the Foundational Questions Institute, FQXI, Anthony Aguirre. I am attending an FQXI conference on time, at sea, in more ways than one, cruising between Norway and Denmark. Anthony, what I thought was an easy question was, did the universe begin? Mm-hmm. Now I hear it's not such an easy question.
No.
Help me.
So it used to be just speculation. Well, the universe was finite in time. Oh, no, it went on forever. And Kant actually went so far as to make this philosophical argument that you could both prove that it was infinite in time and finite. So just throw up your hands. But
then you had the steady state, which theoretically was infinite in time, and the Big Bang, which theoretically had a beginning.
Precisely. So it took this form of these two competing cosmologies.
Right.
And it was nice because we could have observational evidence that would tell us which of those was right. And it turned out that the Big Bang cosmology was right and the steady state was incorrect. But now the steady state has kind of made a comeback through the back door. And we're now at this interesting place in cosmology where we can say that the universe is 13.7 billion years plus a number between 0 and infinity old.
Well, thank you very much for your help.
So, and the way that worked is that we developed this Big Bang model, that the universe at an early time was hot and dense and expanding and so on. And that model has been in spectacular agreement with observation. If you take that model and extrapolate it back, if you just keep running the same laws of physics backwards, you find that just a few minutes earlier, everything goes infinite. So, density goes infinite, everything goes infinite. You've got this singularity, and you say that the universe began, time began. So that's the kind of situation we had in the 60s and 70s, and we felt really good that the universe is 10 billion years, or give or take, old. That's what we thought then. Then in the 80s and 90s, this new idea of inflation came in and said that actually in the very beginning of that Big Bang universe, there was this other phase where cosmology was quite different and the laws were quite different. So then you have to ask, okay, what are the possibilities for how long inflation went on before inflation ended and regular Big Bang that we all know and love began? And the answer is between, some tiny fraction of a second and infinite amount of time. So we're back to the beginning.
How do you get the possibly an infinite amount of time?
The reason is that inflation, once it gets started, can essentially become like a steady state model. It's getting bigger, it's expanding, but its properties that you can observe locally always look kind of the same. And then the question is, how do you get out of that and into the universe that we see? So you have to understand how whatever is making inflation happen, the physics behind inflation, how does that also allow inflation to end in some time and in some place and create what we might call the Big Bang, a bunch of hot radiation and matter and so on. So suppose you take some region of the universe and say, okay, I'm going to set it up so that it's going to do this inflation process. What you can show is that that inflation process in many versions will go on forever. It'll just keep going and going and going. Now, it may here and there stop inflating and create some little pocket or something.
And that universe will have its own little Big Bang.
Exactly.
Whereas other places it would continue to inflate.
Exactly, right.
So we might be in a later inflating universe. So the beginning of our Big Bang, which is the end of our local inflation, is not the same thing as all these other inflations going on all over the place.
Precisely. We know where the beginning of our local region is, where it got hot and then it turned into inflation back then. So that happened 13.7 billion years ago. What we don't know is what's happening elsewhere and what happened before that. And so if this inflation goes on forever in the future, then you can reasonably ask, why did it have to start at all, right? If it sort of becomes a steady state, why not just say it was a steady state, it's always been happening and it always will be happening? So in this model, the universe would all the way back be expanding, but there's no particular reason to say that it started at any particular time.
So if cosmic inflation theory is correct, then our universe had a beginning, but it was almost certainly not the beginning. A beginning, the beginning, minor difference. No, the most major difference. Because cosmic inflation, once started, continues forever, in different places, creating new universes. This means that it would be almost impossible for our universe to be the first universe in an unimaginably long chain of universes. Multiple universes with multiple beginnings. Is this science? Or science losing its moorings? Because multiple universes can never be observed. Still at the FQXI conference, and still at sea, figuratively as well as literally, I meet a cosmologist who has a different approach to the early universe, Andreas Albrecht.
Lots of people have theories about how the universe began, what state it must be in to start with. And they argue with each other, and everyone thinks their theory is the best. It occurred to me that there's a totally different way that's much better to think about these things, and that's to exploit the idea of equilibrium. We know lots of things that are in equilibrium in the world around us. A glass of water, a room full of air can be in equilibrium. Lots of things are in equilibrium, and it means basically physics has taken however it got started and settled it into one particular state.
And it stays there.
And it stays there. So what if we could describe the universe as an equilibrium system? Then the state of the universe could be determined not by someone's theory of the state, but by the laws of physics, taking whatever it was and turning it into a particular state. I knew that was an exciting idea long ago, but it was very hard for many years to imagine how you could have a theory that looked like the universe around us. All that changed when we discovered the cosmic acceleration, when we realized maybe to understand the universe better, we need to introduce something called a cosmological constant. It turns out that if there really is a cosmological constant driving this acceleration, then you actually get a nice equilibrium picture in the future of the universe. The answer is at the end you reach equilibrium.
How does acceleration reach equilibrium at the end?
The acceleration, if it's described by a cosmological constant, you add a term to Einstein's equations that quickly comes to dominate. If you take pure de Sitter space and throw junk in it, like black holes or anything else, as the space then evolves, the stuff kind of spreads out and gets pushed up to the horizon, and you return to the equilibrium state. It's a state you achieve when you wait long enough and let the system settle. So every feature is one of an equilibrium system. There's all kinds of fluctuations in an equilibrium system, And in my theory of cosmology, the Big Bang, is a fluctuation from that equilibrium state. And we're just returning to equilibrium now. So we're riding this Big Bang back to equilibrium once the cosmological constant truly dominates.
And as space expands, cosmological constant gets more and more important because there's more and more space, and the cosmological constant is constant within each volume of space.
So all the other matter dilutes as the cosmos expands. The cosmological constant doesn't.
Right.
So it eventually dominates. And as it dominates, we approach the equilibrium.
Right.
And so in that picture, the Big Bang, as we know it, the early stages of the universe, the formation of nuclei, all these things, all started with a fluctuation.
And that fluctuation is a quantum fluctuation.
That's a quantum fluctuation.
And that occurs whenever it occurs. It can be enormously infrequently, but when it occurs, that's what's the little seed.
It's a little seed.
That grows through the inflation process and creates our universe.
And the key there is inflation, because what inflation can do is take a small seed and make a big universe. That's got to be good. It's run into trouble because lots of the realizations of inflation have had problems with infinities and all kinds of disastrous technical issues. But this picture, the equilibrium picture, actually realizes the original idea of inflation, that inflation is good because it can take a little thing and make a whole universe.
Quantum fluctuations, the instability of empty space that generates particles and antiparticles which instantly annihilate each other. But on exceedingly rare occasions, these quantum fluctuations do not annihilate each other, but become the little seeds that grow by gravity over billions of years to become the great galaxies of our universe. What an all-encompassing unity. So here's the challenge to the common science of how the universe began. Quantum fluctuations in multiple universes, generating the very largest structures from the very smallest particles, and rejecting the common belief of a single beginning to a single universe. Now, what's the challenge to the common theology of how the universe began? I meet an Anglican priest with a doctorate in astrophysics, Rodney Holder. Rodney, I know you're a theologian, but you're also an astrophysicist. And from both perspectives, how do you view the beginning of the universe?
Well, I think naively, with classical general relativity and so on, you would get a beginning at the Big Bang on the sort of standard cosmological models. But there are problems with that. Because physics actually runs out. General relativity breaks down as you go back towards t equals naught, if you like. So certainly it looks like our space-time realm has a beginning, but whether that can be identified with the beginning of the universe, I would be unsure about. And actually, I've been reluctant to, and indeed, I simply haven't done it, made an argument about for the existence of God from the universe having a beginning. Some philosophers and theologians do that, but I've not done that, because I would want to question that that's the role for God. To, as it were, light the blue touch paper and set everything off. To me, every moment is a gift from God and is willed by God to exist.
So do you privilege God as the sustainer more than God as the creator?
Well, I think the two are intimately interlinked. I think God is continuously creating, if you like, by upholding the laws he is instantiated.
Okay, but now you're defining sustaining as continuously creating.
Essentially.
So you, either with your astrophysicist hat or with your theologian hat, are not wedded to a literal beginning of the universe per se, out of nothing.
That's correct. The beginning of the universe is not a problem for theologians, whether it has one or not, temporarily. It's been more of a problem for atheists, like Fred Hoyle and the steady-state people who hated the idea of the Big Bang.
Because if you have an eternal universe, you don't need an initial
No.
event.
No, that's right. But God can create a universe with an infinite past, just as that's not a problem for God. So
you would look at God in a universe that had no beginning, that had an infinite past, as the cause, or we say the ontological, the fundamental being a creator of it, but not the creator in a time.
Precisely. Ontologically, he is prior to the universe, not necessarily temporally. God isn't really needed to light the blue touch paper. He's needed for there to be anything at all. That's the theological question, the question that was posed by Leibniz, way back. Why is there something rather than nothing? That's the fundamental theological question to which God provides the answer, rather than a beginning in time.
Here's the common theology, which Rodney challenges. Everything that begins to exist has a cause. The universe began to exist, therefore the universe has a cause, which many call God. So, just as some science challenges the idea that the universe began to exist, some theology mounts a similar challenge. I guess it's safer for theologians to avoid beginnings. One never knows when new science will undercut old theologies. But then, what does it mean that God is ontologically, existentially prior to the universe, though not necessarily temporally prior? I asked the professor for systematic theology at Martin Luther University in Germany, Dirk Evers.
There is a traditional distinction between God as the cause of the world or God as the reason of the world, causa or ratio in Latin. And I would say that if God is the reason of the world, it's the fundamental ground of being, then it is not necessary to think of a beginning of the universe in order to think of God as the creator. He can be the eternal reason of an eternal creation. It is also not very clear how can we really grasp the idea of a starting point, of an absolute beginning. What should that mean? Nothing before it? Does time end there? Does time begin? Already the term to begin is a temporal term. So I think we do not have a real clear, distinctive notion of an absolute beginning. Even if you refer to Big Bang cosmology, some would say, okay, before that there was some kind of quantum effect in the void or something. Yeah. So you always have to presuppose something out of which this beginning arises.
If we assume that God is the reason for an eternal universe, which you find completely consistent with an idea of God, it seems like that emulsifies God into a wispy thing that is rather amorphous, because if you can have God being the cause of this thing that always existed, well, the thing itself is always existing. It's its own cause. I mean, there's no difference between the universe always existing and the universe always existing because God is the cause. It seems like that's just an added term that means nothing.
That's indeed a problem, but it's only a problem if you would say that the universe, the cosmos, is something that is always more or less the same. But the cosmos shows a very deep and fundamental development. And it still leaves open the question, what does this cosmos as we have it now, in which we are existing, out of which we arise, what does that have for a meaning, and how is that related to the ground of being?
To Dirk, God would be the reason for the world, even if not the cause of the world. If the cosmos is eternal, without beginning, God would still be the ground of its being. But I struggle with this. Why not, more simply, a cosmos existing eternally by itself, without God, without a ground of being? Adding God adds what? Dirk offers a teleology of sorts, the claim of cosmic flow toward human existence. Well, most scientists will have none of this. To them, whether or not the universe has a beginning, God is very much not needed. I meet the co-author with Stephen Hawking of The Grand Design, physicist Leonard Mlodinow. Len argues that the nature of time, not the manipulations of God, explains the origin of the universe.
When we ask how something begins, we think about maybe something that we see in the present, and we trace it back in time to a point where before which it didn't exist, and so that's the beginning. That assumes that time is the way we learn about it in school, which is a linear, a number like a number line, and there's a zero, and then there's beyond the zero. But modern physics tells us that time isn't really like that. The universe, as we go back in time, was smaller and smaller and smaller. And we also know that as all the matter and energy gets squeezed into the smaller parts of the universe, they start to affect each other through general relativity, because it tells you that matter affects space and time, which affects matter, and then you have to start taking into account that time and space can get warped. And when you get early enough in the universe, you also have to take into account quantum theory, which means that all the energy and fields of the universe are having fluctuations. And when you put all that together, those fluctuations, the effect of those fluctuations, all the matter being tightly squeezed together, and the warpage of space and time, what you get is that time becomes so warped that it doesn't have the meaning that we think of it as having today. So it's not like a straight line, it's more like, let's say, a globe, where time is a line of longitude that goes around the globe. It curves, and as you get near the pole, it's hard to tell which is what's east and what's west, and time and space kind of get mixed together, and it doesn't really have a beginning in the way that we think of it.
How far back can you go before it begins to have this real weirdness, and how big is the universe at that point?
Well, we can go back with our theories of physics to certainly inflation, the period of inflation, for instance, where quantum effects were important, around 10 to the minus 33, 34 seconds.
And at that point, the universe is how big?
Well, it depends when. It could be grapefruit. I mean, what does that even mean? But it's a fruit-sized universe, you know,
Right.
Our observable universe, that is,
right.
because we believe the universe is infinite. So,
Right.
But the observable universe that we can see today, that light can still reach us, that can affect us, is that size. And when we go back that far, we know that we have to take quantum effects into account, and we know that time ceases to have its current character. So we don't have a feeling for what time means. We don't have an intuition for what time even means.
How then do you answer the question, did our universe have a beginning?
Well, my answer to the question is that it didn't have a beginning in the usual sense, because you can't trace time back that far, and the question doesn't mean anything. You can get back to as small as you want. It starts from a point, but
Right.
quantum theory tells us we can't quite look back that far.
Right.
That's not the beginning. I mean, for most people, maybe that's close enough to the beginning. I mean, to me, the fascinating thing is that, okay, that before inflation, the universe was homogeneous, like everything was put in the blender and stirred up. It wasn't really put in, it started in the blender state, and with time, it formed the clumps.
Yeah.
That's the miracle of inflation, is to show that is microscopic quantum fluctuations turn into clusters of galaxies and stars. That is just amazing. That is our origin.
So, did the universe have a beginning? Well, what's the universe? And what's a beginning? It is proper to ask whether our universe had a beginning, but not necessarily whether the totality of the cosmos, all that exists, had a beginning. So did our universe have a robust, something from nothing beginning? Science and theology can each challenge this conventional wisdom. Science can invoke multiple universes and the nature of time. Theology can recruit God as reason and sustainer, not as cause and creator. Some scientists claim that our universe fluctuated into existence out of a previous universe. Others that the notion of a beginning is incoherent because Einstein's relativity warps space-time and quantum mechanics generates instability. As for God, if the entire universe, all that exists, goes infinite into the past, to say God is the reason, if not the cause, is a statement of faith, not of science. Beginnings are clues. Beginnings are closer to truth.
For complete interviews and for further information, please visit closertotruth.com.